All right, today we're going to look at the Pythagorean theorem of baseball. You are going to be using this method to sort of estimate a team's winning percentage in baseball, basketball, football, whatever sport you choose, based on how many runs or points they score and how many runs or points that they give up. We're going to go through an example for baseball. I'm going to allow you to choose which sport you would like to complete. So the Pythagorean theorem of baseball was created by Bill James. You can see that it's similar to the Pythagorean theorem, a squared plus b squared equals c squared, and that's kind of where it got its name from. So the first thing that we're going to do is we're going to go to the website baseballreference.com, and we're going to click on seasons, and we're going to go to the 2018 Major League Baseball team stats. That's going to bring us to this website. We're going to scroll down to the team standard batting, and we're going to click share and more and get table as CSV. Now we've got this table of comma separated values. What we want to do is we want to highlight this entire table, and we can do a copy, Control C to copy. And then we want to go to our spreadsheet. So you should have a spreadsheet open. And we want to do a right click in cell A1 and paste special. And we're going to paste text. If you're working in Google Sheets, this works similarly to this as well. Now you've got this in here. Don't click anywhere. What we want to do is we want to convert this to columns. So we're going to go up to data, and we're going to go over to text columns and click that. We want to click next, and our data is separated by columns, so we're going to get rid of the tab here, and we're going to check the box for comma. And go ahead and click next and finish. And you can see that now our data looks much cleaner. We're going to go back to this website. We're going to scroll down a little bit to the pitching statistics. And we're going to do the same thing here. We're going to get the table as a CSV. We're going to highlight it. And we're going to do a Control C to copy. Go back to our spreadsheet. And we're going to go out to the end to this empty column here, AD. And again, we're going to do a right click, paste special text. And you'll see this time we didn't have to worry about doing the text columns because now the spreadsheet kind of understands what we want. You're going to do this for 5 years worth of data. So I've got 2018 here. You're going to do it for 18, 17, 16, 15, 14. Once you have all of that done, we're going to clean this up a little bit because we don't want all of this information. So up at the top, we're going to click and hold so that we highlight these cells here. We want to keep the team cell, and the next one we want to keep is the run cell. So we're going to highlight B through G. It's going to right click while we're up there and do delete. Now we're going to highlight, click again. We're going to hold this down. We're going to scroll all the way across until we get to the column that starts with a W at the top for wins. And we're going to again right click and delete all of those columns. We're going to keep L, losses. We're going to keep win-loss percentage. But now we want to come over here to ERA. And again, we're going to highlight all the way over to runs. And we're going to right click and delete those columns. We're going to keep that runs column. And then we're going to highlight ER, earned runs, all the way over to the end, right click and delete. So now you should have 5 years worth of data where you just have these 6 columns here. So now we're ready to kind of start investigating this. So what Bill James' formula says is that there's going to be some exponent. Okay? And we'll just put that up here. And we start off with just saying, let's say 2 is the exponent. Okay? What we're going to do is we're going to take a team's runs scored. So in this case, that's column B2. And we're going to set up a formula, so equals, and we're going to click that B2. We're going to raise that to this exponent. So B2 raised to the H1 power. And we're going to divide that by the quantity B2 to the H1 power plus F2 to the H1 power. Okay? So we're taking the runs scored raised to this exponent, and we're dividing it by the runs scored to that exponent plus the runs against to that exponent. And then there's one more thing we want to do. We're going to copy this formula all the way down. So we want to make sure that we get rid, or we add a dollar sign in front of this 1, in between the H and the 1. That way when we copy this down, it'll continue to use the exponent 2. So we go ahead, we hit enter, and there it gives us an estimated winning percentage for Arizona. Now their actual win percentage was 0.506. Our estimated winning percentage here is 0.5366. We can just double click that bottom right corner, or if you're in Google Sheets, you're going to have to click and hold and drag it down to the bottom of your data. One other thing that we're going to do is we're going to come down here, and everywhere that you see league average and then this blank row here, we're going to highlight, so click and hold, highlight those two and delete. So you might have to do that 4 or 5 times for your data. But we don't want that data. We just want each team and their win-loss percentage. So now this is what column E is our actual win-loss percentage. Column G is our expected win-loss percentage. So what we want to do is we want to calculate what's called the mean average deviation. Okay? Mean absolute deviation. We're going to take the absolute deviation for each one of these win-loss percentages. So to do that, we're going to take equals, and then ABS will return the absolute value. So ABS parentheses, and then we're going to take E2, the actual win-loss percentage, and we're going to subtract G2, the predicted win-loss percentage. And then hit enter, and then again, take that all the way down to the bottom. So now we have basically for each team, how far off was our prediction? So what we're going to do is up here in I2 or I1, let's type in mean average deviation. Okay. And to make that a little bit bigger, you can just either click in the middle of these two columns and drag, or you can double click and it will resize it for you. And for our mean average deviation, the formula would just be, we're taking our mean absolute deviation, we're just going to take equals, and then we want the average of all of these absolute deviations. So H2 down to H31. So now we've got, on average, the win-loss percentage was off by about 0.023. If we want to know how many games was that, well, there are 162 games in a Major League Baseball season typically. So if we multiply that number, equals I2 times 162, it tells us on average we end up about 4 games off, not quite 4 games off. So that's a pretty good estimate for the actual win-loss percentage of a team. But maybe it could be better. Maybe this 2 isn't the best exponent. And so to determine that, what we're going to do is we're going to click on this what if analysis we're going to click Solver. If you're in Google Sheets, you're going to use the solver there as well. So we want to go to the solver. And what we want to do is we want to set our objective to be I2, or wherever you have this mean absolute deviation. And we want that to be a minimum. We want it to be as small as possible. That tells us that we're as close to the actual win-loss percentages as we could possibly get. And we're going to do that by changing H1, this exponent up here. Okay, so again, we're setting the objective of I2, the mean average absolute deviation, by changing H1, the exponent. And then you can go ahead and click Solve, and it should come up with an answer pretty quickly. And we can see that it changed this answer to 1.837, the exponent now. Let me just fix this again. Remember, it's mean absolute deviation. So our exponent we actually want to use is 1.837 instead of the 2 that we started with. That gives us a mean absolute deviation of 0.023 and about 3.65 games off on average. Okay. What we can see too is we could go down this list and we could look for which ones were off by the most. We can see, for example, St. Louis was extremely close. 0.543 was the actual, 0.543 was our predicted. Okay. But we can also see some of them we were a little bit further off. We've got Baltimore here. They actually won 29% of our games, and we would predict 34%. Another one that was fairly far off was the Dodgers here. They won 56%. We would have predicted 62%. Okay. Another one that was really close, Minnesota. They won 48%. We predicted 47.8, so about 48%. Okay. This is a fairly simple but accurate way to use just the runs scored and the runs against to predict the win-loss percentage of a team. Your job is going to be to use Microsoft Excel or Google Sheets to do this based on 5 years worth of data from either baseball, football, basketball, or some other sport of your choosing, as long as you can get the offensive points or runs, the defensive points or runs given up, and then the win-loss record so that you can get a win-loss percentage. You may need to calculate the win-loss percentage depending on where you get your data from. There is a website, basketballreference.com. There is a website, footballreference.com. Those would be excellent places to look. One other thing, if we look at this Pythagorean theorem of baseball here on Baseball Reference, they do mention runs scored squared divided by runs scored squared plus runs allowed squared. But then it said more accurate versions of the formula use 1.81 or 1.83 as the exponent. So we should feel pretty good about getting this 1.837 as our exponent just using one season's worth of data. We're going to want to use multiple seasons, though, to hopefully make sure that our estimate is as accurate as possible. Okay. So again, just to wrap up, create a spreadsheet where you import data for a specific sport, points for, points against, wins, losses, win-loss percentage. And then you're going to use this Pythagorean theorem formula expectation to come up with an exponent that gives you the smallest mean absolute deviation. Thank you.